the nomenclature of ketones. So as we know, the organic compounds generally will have two names. One is common name and the other one is IUPAC. So you know that the common names are origined, means common names are given based on the sources from which it is extracted, and IUPAC name is given based on set of rules, that is called as IUPAC rules. Okay, that is, it will follow the sequence prefix, word root and this suffix. Okay. Yes, here the common name will have the sequence like this: alkyl or aryl ketone. Okay, means at the end the class of the compound is given as it is. Okay, and in the IUPAC name we are going to use the suffix. The suffix for ketone is one. The suffix for ketone is one. So it is called as alkanone. Okay, alkanone. If suppose benzene is present, okay, phenone we call. Okay, yes, let us have some examples. Okay, first member of these ketones is acetone. Okay, whose formula is like this: CH3, C double bond O, CH3. This is the first member of ketones, that is with the 3 carbon atoms. Okay, because it will have the formula like this: R C double bond O R dash. This is the general formula of ketones. Okay, and here the common name for this is acetone. You have to remember this compound because it is having many advantages in industries. For example, the acetone is used as a nail polish remover. Nail polish remover. Okay, and it is one commercial name or common name for the compound. Okay, and it is also called as dimethyl ketone. Dimethyl ketone. Here we can see there are two methyl groups on this carbonyl carbon, therefore it is called as dimethyl ketone. We can call the acetone as dimethyl ketone. Dimethyl ketone. See here, it follows the general sequence. Okay. Yes. What is the IUPAC name of this compound? How many carbon atoms are there? 3. Therefore, it is pro. Okay. Propane, for hydrocarbon we call it as propane. If you write that, propane. Here we have a functional group, that is ketone. For ketone, what is the suffix? ONE, one. Okay. So therefore, here you should replace this E with the ONE. So it will become propanone. It will become propanone. Okay. Yes. Let us go for homologous series of this. Okay. And here, what is the homologous series? The structurally related compounds having same molecular formula but difference in the CH2 group. Okay. Yes. That is CH3, CH2, C double bond O, CH3. So what are homologous series? The series of compounds having same functional group, same general formula, and will be differ by a CH2 group. Okay. Now what is the common name of this compound? Here you can see ethyl group is present. Here methyl group is present. Which one will come first alphabetically? E of ethyl comes first. So therefore ethyl methyl ketone. So what is the name of this compound? Ethyl methyl ketone. Ethyl methyl ketone. Now what is the IUPAC name of this compound? How many carbon atoms? 4 carbon atoms are there. Butane, butane and ONE. Suffix for this carbon. So it is called as a butanone. It is called as a butanone. Okay, let us also consider whether isomers possible for these compounds or not. Let us take the isomerism for this. Whether this compound shows isomerism or not. Okay, here the aldehydes and ketones are functional group isomers. As we have discussed in the earlier class, all the ketones are having the functional group isomerism with the aldehyde. Okay, Yes, these can show the functional group isomerisms. Functional group isomerisms. This show functional group isomerism with the propanol. Okay, and this butanone shows functional group isomerism. With butanol. Means corresponding aldehyde. Propanol shows functional group isomerism with the corresponding aldehyde, that is propanol. Butanol shows functional group isomerism with the corresponding aldehyde, that is butanol. And this acetone and this butanol cannot show the chain isomerism or position isomerism. The first two compounds cannot show the chain isomerism or position isomerism. Let us go for the higher members. You know that higher members of any class of compounds will show more number of isomerisms. Let us go for the pentanone, for example. The next higher member in this series is pentanone, means with the 5 carbon atoms. Okay, let us take that. CH3, CH2, CH2, C double bond O, CH3. Okay. So what is the common name of this compound? Here we have propyl, here we have methyl. Which one will come first alphabetically? M of methyl comes first, then the P of propyl. Therefore, it is called as methyl propyl ketone. So what is the common name? Methyl propyl ketone. Now, what is the IUPAC name for this? Pentanone. Here we will give you the number 1, 2, 3, 4, 5. So it is pentanone. Okay. Let us see isomer for this molecule. Okay. Yes. Come to this. We can have rearrangement in this. CH3, CH2, C double bond O, CH2, CH3. See, when you number these carbon atoms, you can come from left to right or right to left. You can choose any way. But here, if you move in this direction, 1, 2, 3. Third is the position for this carbon, and here also 1, 2, 3. You are getting the same. But in case of this, the lowest number will be given when you move from this end. Okay, that is why you have to move in this direction. If you move in this direction, that is from left to right, 1, 2, 3, 4. Okay, so in this way 2. So 2 is the lowest number, no? So you have to choose this way of giving the numbers. Okay, and here the third carbon is having the double bond O. Therefore, it is pentanone. IUPAC is pentanone. Okay. Then what is the common name? Here this side you have ethyl group, here also ethyl group. There are 2 ethyl groups, therefore you can call it as diethyl ketone. The common name of this compound is diethyl ketone. Now observe these 2 compounds having same molecular formula, okay, but differ in the position of the carbonyl group. Therefore, these two are position isomers. That you can easily understand by looking at the IUPAC names. Pentanone. What is the difference? 2 and 3. Therefore, position of the carbonyl group is different. Therefore, these two are called as position isomers. Then what is next? Whether this pentanone will exhibit the chain isomerism? Let us see. Chain isomerism is what? 2 or more compounds having the same molecular formula, but difference in the number of carbon atoms in the parent chain. Okay. Yes, let us see. Here in the parent chain you have 5 carbon atoms. Now let us rearrange it. CH3, C double bond O, CH, CH3, CH3. Okay, we have rearranged the 5 carbon atoms in this way with a branch. Okay, and while writing the structure of the compound, you have to consider the tetravalence of carbon atom, monovalence of hydrogen, and divalence of oxygen atom. Means the carbon must have 4 bonds. Okay, oxygen must have 2 bonds. The hydrogen must have single bond. That you have to remember always. Okay. Now, what is the common name of this compound? This side you have methyl. This side there are 3 carbon atoms, but these three are not in a parent chain or not in a single chain. These have a branch. So therefore, we can call it as isopropyl. This is called as isopropyl. So methyl isopropyl ketone. So what is the name of this compound? Methyl isopropyl ketone. Methyl isopropyl ketone. Okay. Then what is the IUPAC name? So we have to give the numbers 1, 2, 3, 4. Why I am giving the numbers from left to right? Because this will get the lowest number. The functional group will get the lowest number. If you move from this end, that is right to left, what happens? 1, 2, 3. See here, functional group containing carbon is getting 3 as a number. So we have to follow the lowest sum rule. Means what is the lowest sum rule? The functional group containing carbon must get the lowest number. So in this way it gives the lowest number. So and again at the third position there is a branch methyl. Okay. So where it is present at the third carbon, no? So it will be taken as a prefix. Okay. 3 methyl. 3 methyl. Okay. 3 methyl. Word root is butan because 4 carbon atoms are there. Butan 2-one. Butan 2-one. 3 methyl. Butan 2-one. See, these two compounds are having same molecular formula, but difference in the number of carbon atoms in the chain. In this chain you have 5 carbon atoms. In this parent chain you have only 4 carbon atoms. No? So therefore, these two are said to be chain isomers. These two are said to be chain isomers. Here what we are understanding from this example, the first member can exhibit only functional group isomerism with the aldehyde. The second one also. But the third one, that is pentanone, is able to exhibit the position isomerism, the chain isomerism, and also the functional group isomerism, also the metamerism. So what is metamerism? For example, these two are called as metamers. Okay, on this side you have propyl, on this side you have methyl. But when it comes to this end, this is ethyl, this is ethyl. Okay, so it is difference in the groups on either side of the functional group is called as metamerism. So here pentanone can exhibit a variety of isomerism. That's what I am going to say is, the higher members of the family will exhibit more and more number of isomers, more and more number of isomers. This is all about the aliphatic ketones. Okay, let us consider some cyclic ketones. For example, you take the cyclohexa. What is this cyclohexa? And put double bond O to this. Okay, what happens? There are 6 carbon atoms in this ring. So cyclohexa. Okay, and ketone. So suffix is none. Okay, cyclohexanone. Okay, what is the name of this compound? Cyclohexanone. This is the simple alicyclic ketone. Let us consider some unsaturated ketones. Unsaturated ketones. For example, CH3, C, CH3, double bond, CH, C double bond O, CH3. What are called unsaturated ketones? The ketones with the C double bond C or C triple bond C will be called as unsaturated ketones. Okay. This is one of the unsaturated ketone now. What is the common name? Its common name is methyl oxide. Its common name is methyl oxide. You need to remember the common name. Okay. Yes, what is the IUPAC name of this compound? See, again we have to choose the lowest sum rule. In this parent chain you have 5 carbon atoms, and here we have a carbonyl functional group and double bond. In these two, this will take the preference. So therefore we have to start numbering from this carbon. 1, 2, 3, 4, 5. So what is this? Now we have a prefix 4-methyl, 4-methyl, then bute, 5 carbon atoms are there. Bute, where it starts, the double bond starts from 3rd carbon atom. So bute 3, bute 3. See, usually we have to write E and E here, but due to the presence of one more functional group, that is what? Ketone, means ONE will be the suffix. Under the position 2, you have to replace this E and write 2-one. So what is the IUPAC name of this methyl oxide? 4-methyl, bute 3, 2-one is the IUPAC name. Okay. Yes. Let us go for some aromatic ketones. Aromatic ketones means what? The ketonic group is directly present on the benzene ring. Let us see that. Okay. Let us consider a simple aromatic ketone. For example, we have a benzene ring, C double bond O CH3. This is called a simple aromatic ketone because R we have, okay, CO R dash. Okay. Yes, here the benzene ring will give the aromatic character. This C double bond is directly present on the benzene ring. Okay. Now here the functional group is carbonyl is present in the open chain. Okay, again we have to give the numbering 1 to this because containing functional group, 2 to this. Okay, this is a open chain compound. Okay, what is present on carbon 1? The benzene ring or phenyl ring is present. So we have to write 1-phenyl ethanone as the IUPAC name. 1-phenyl ethanone. 1-phenyl ethanone is the IUPAC. Then what is the common name of this compound? Common name is acetophenone. You have to remember all the common names and IUPAC names, okay, of these compounds. Yes, this is generally called a acetophenone because this refers to the acetone, this refers to the phenone, okay, acetophenone, okay. Other than this, we can also give one more common name. This is phenyl, this is methyl. So M of methyl comes first, no? Therefore, methyl phenyl ketone. We can also call this as methyl phenyl ketone. Or simply acetophenone. Most of the times in the book or in the question paper, we use this acetophenone. Okay, so have an idea about these things. Okay, then we shall go for the next one. Okay, we have a benzene ring, then C double bond O, CH2, CH3. See, this is called as a propionophenone. This is, yes. And accordingly, the common sequence we can call this as phenyl ethyl. Okay, which one will come first? Ethyl. This group is ethyl, no? Ethyl phenyl ketone. We can also call this as ethyl phenyl ketone. Okay. Here the C double bond O refers to the ketonic group. Okay. Yes, ethyl phenyl ketone alphabetically. Okay. Yes, what is the IUPAC name? Again, we have to select the open chain because the functional group is present in the open chain. this is carbon 1, 2, 3. So 1 phenyl, okay, propanone. 1 phenyl propanone. 1 phenyl propanone is the UPAC name. Okay, come to the next compound. For example, a compound is having two phenyl groups on carbonyl carbon. Then what we can call this as? Initially it was called as aceto. This is a phenol. This is a phenol. This is a benzo. Because benzo is there, no? Benzo. Benzophenone. The common name is called as benzophenone. Benzophenone. Or in other way, we can call this as diphenyl ketone. Diphenyl ketone. Because two phenyl groups are there, no? Diphenyl ketone. This is also called as diphenyl ketone. Okay. Then what is the IUPAC name? See, open chain carbon is there. Only one carbon is there. Okay. On that carbon, two phenyl groups are present. So we can call this as 1,1 diphenyl. 1,1 diphenyl. How many carbons? One carbon. Methane we say. For hydrocarbon methane here. Suffix ONE should be added, so therefore methanol. So what is the IUPAC name of this compound? 1,1 diphenyl methanol. Okay, so this is all about the common names and IUPAC names of the ketones. Now let us discuss about the structure of carbonyl group. Let us see what idea we are going to get it from this discussion. Okay, let's take the carbonyl group. It will be like this. Okay, means there will be a C double bond O. These bonds will be connected to the alkyl or aryl groups. Okay. And here you can see that this carbon is surrounded by 3 sigma bonds. Okay, 1, 2, this is 1 sigma, this is another one, is 5. So whenever a carbon will have 3 sigma bonds, then it will be in the sp2 hybridized state. sp2 hybridized state. And the carbon, when it is taking sp2 hybridization, the bond angle will be 120 degree. Okay. And the geometry will be trigonal coplanar. Okay. So here carbonyl carbon is sp2 hybridized and making the bond angle 120 degree and the shape is trigonal coplanar. Okay. And let us understand from this, okay, due to the presence of electronegative oxygen, it pulls electrons towards itself and makes the molecule as polar. Okay, let us see that the oxygen is more polar. Okay, oxygen is more electronegative. It will pull the pi electrons onto itself and starts polarity. Okay, and it can be shown by the resonance structures. Okay. When the oxygen pull electrons towards itself, this will become O minus, and due to the loss of electrons, this carbon will gain positive charge. Okay. This is the electronegativity difference between the oxygen and carbon is inducing the polarity. In this molecule. Okay. So the ketones or aldehydes are polar in nature. Due to this polarity, these are the lower members of the carbonyl compounds are miscible with water. Because water is a polar dissolves in polar, means when you take the aldehydes such as acetaldehyde, it is readily soluble in water. When you take a ketone like acetone, it is readily soluble in water because these are polar in nature and are soluble in water. Okay, yes. And also we have to understand that here the carbon is an electrophile. Here carbonyl carbon. Carbonyl carbon is acting as electrophile. Is electrophile. Okay. And it is called as electrophilic center. It is a electrophilic center. Carbon is electrophilic center in this molecule, and the carbonyl oxygen is nucleophilic center. What is electrophilic? Means electron deficient. Okay, what is nucleophilic? Electron rich. So here carbonyl carbon is electrophilic center. Therefore, it will be attacked by the nucleophile. It will be attacked. Means this will be attacked by the nucleophile. Means electron rich. Therefore, we say the carbonyl compounds undergo the nucleophilic addition reaction. Okay. Therefore, the carbonyl compounds. Therefore, carbonyl compounds. Carbonyl compounds undergo nucleophilic addition reactions. Nucleophilic addition reactions. The carbonyl compounds such as aldehydes and ketones will undergo the nucleophilic addition reaction. Why it undergo nucleophilic addition reaction? Because here we have electrophilic carbon atom. Okay, electron deficient carbon atoms. Okay, so what we have understood from this discussion, carbonyl compounds are polar, where the carbon is electrophile and it will be attacked by the nucleophile. Therefore, the carbonyl compounds undergo nucleophilic addition reactions. Let us discuss about general methods of preparation of aldehydes and ketones. Here we have some general methods. When you conduct that method, there is a chance for getting the aldehydes as well as ketones. Okay, let us see what are those methods. The first one is oxidation of alcohol. Oxidation of alcohols. This you have studied from the unit alcohols, phenols and ethers. Okay. You know that when primary alcohol is oxidized, you will get aldehyde. The secondary alcohols on oxidation gives the ketones. Okay. So it is already discussed. Okay. Here I am going to give you the general reaction equations. Okay. Let us take a primary alcohol that can be denoted like this. The functional group containing carbon is linked to only one other group or one other carbon. So therefore it is called as a primary alcohol. When it is treated with the oxidizing agent like chromium trioxide, it will undergo oxidation. Oxidation means what? Loss of hydrogens or addition of oxygen. In this case, oxygen is already there. You can see the elimination or removal of hydrogens. Okay, it will give RCHO. So this is the aldehyde now. You can write your own example here. For example, R is CH3, CH3CH2OH, that is called as ethyl alcohol, and you will get a CH3CHO, that is ethanol, AL. Okay, or acetaldehyde you will get. Okay, these examples already discussed in the alcohols chapter. Okay, and let's see what happens when a secondary alcohol is taken. Okay, take the secondary alcohol like this. R, C, R dash, HOH. Okay, so here functional group is this, containing carbon is this, is linked to two other carbon atoms. So it is secondary alcohol. It is secondary alcohol. When it is treated with the oxidizing agents like CrO3, it will be oxidized to the ketone, that is R C double bond O R dash. This is what ketone. Hydrogens are removed from the structure. Okay. Yes, this you need to remember. Say the oxidation of alcohols with CrO3. CrO3 is what a mild oxidizing agent. Mild oxidizing agent. See, if you oxidize the alcohol with mild oxidizing agents, then you can see the aldehydes and ketones. If you use the strong oxidizing agents like KMnO4, K2Cr2O7, it will directly convert the alcohol to the corresponding carboxylic acid. That is why we should not use the KMnO4 or K2Cr2O7 in this reaction. That is why we have to use the weak oxidizing agents like CrO3. Okay. Yes. Next we shall see the dehydrogenation of alcohols. By this method also we will get the aldehydes and ketones. Yes. What is the second one? Dehydrogenation. Dehydrogenation is also the removal of hydrogens. Okay. So what is it? D stands for removal. Okay. Hydrogenation, hydrogens. Okay. Dehydrogenation of alcohols. Dehydrogenation of alcohols. Let's take the same equation. This can be done either by using copper or silver. The dehydrogenation can be done either by using copper or silver metals. Let us take one example. When primary alcohol is treated with copper metal at high temperature like 573 Kelvin, you will get RCHO. That is aldehyde. That is aldehyde. Okay. When a secondary alcohol, for example, this is what a secondary alcohol is treated with copper metal at high temperature 573 Kelvin, you will get RC double bond R dash plus H2. H2 is released from this structure. Okay, this is called as dehydrogenation of alcohols using copper or silver. Okay. Here you can take the general examples by putting R as CH3, R dash also as CH3, no problem. Okay, you can make your own examples. Okay. Yes, the third method is ozonolysis. What is ozonolysis? It is lysis means breaking of a bond. Lysis means breaking of a bond by the addition of ozone. So it is called as ozonolysis. Breaking of a bond by the addition of ozone is called as ozonolysis. We are doing this on alkenes. Okay, let's take alkenes. For example, any alkene, you may take CH3, CH2, CH double bond CH2. What is this? 1-butene. This is 1-butene. When ozone is added to this, when ozone, that is O3, is added to this, what happens? It will form a cyclic ozonide. Where there is unsaturation, here there is unsaturation. Here the O3 molecule will attack. Breaking of bonds between carbon and carbon takes place. Okay. Now remaining part will be as it is, like this. CH3, CH2, CH. Okay. And here we have CH2. No, take that CH2. Okay. These are separated now. Ozone is added, and that will attack on the unsaturation like this. It will make a cyclic ozonide structure like this. Okay. O3 will be inserted into this. Now it is called as a cyclic ozonide. cyclic ogenide. Yes. Then when zinc dust is added to this, followed by addition of water or followed by hydrolysis, what happens here? This bond will be taken this way. Here there is a C single bond O, no? Now it will become C double bond O. Now this is here having 4 bonds. When it will make a bond, becomes 5 bonds with this carbon. That is what it will do. This breaks this bond. Okay, means it will go here and makes a double bond, and this oxygen will come away and joins this H2O and forms H2O2. So what is the byproduct here? Hydrogen peroxide, H2O2. Okay, what happens? CH3, CH4, C double bond OH. Okay, here we can write CH3, CH2, CHO, CH3, CH2, CHO. CHO is nothing but C double bond OH. Okay, and what is its name? Propanol. It is a propanol. It is an aldehyde. Okay. What is this? CH2 and this C is having double bond O now. Okay. HCHO we can call it. What is that HCHO? Methanol. HCHO is called as methanol. And we know the common name, that is formaldehyde. The common name is formaldehyde. Okay. Here both the obtained products are aldehydes. Okay. Then to get ketones, the unsaturated carbon, this carbon must have 2 carbon atoms linked. Okay. Let us consider CH3, CCH3, double bond CH2. See, this is what one butene, no? Isomer of this is this. That is a we can call this as isobutene. In common system, it is called as isobutene. Or IUPAC is 2-methyl propene. 2-methyl propene. This is a position 1, this is 2, no? So at the second carbon atom there is a methyl, 2-methyl propene. Okay. In the common system, it is called as isobutene. Okay. See, these two, 1-butene and isobutene are isomers, but will give different products now. Okay. When this is treated with ozone, gives a cyclic ogenide like this. Here unsaturation is there, no? Here the ozone will attack CH3, C, CH3. See how I am going to write this like this. This C carrying 2 CH3 groups and the ozone is inserted. Okay, here we have CH2, O, like this. Okay, this is called a cyclic ogenide. Cyclic ogenide is a common name. Okay, when it is treated with a zinc followed by hydrolysis, what happens? Here this oxygen makes a double bond with this carbon, this leaves and makes a double bond here, this oxygen comes out and joins with H2O. Now it will be forming H2O2. This is coming out. Now this is a CH3, C double bond O, CH3, C double bond O, CH3, and what is this? HCHO again. And you can write CH2O, no problem. Okay. So what is this? Acetone. The common name of this compound is acetone, or IUPAC name is propanol. Then what is this? Common name is formaldehyde. The IUPAC name is methanol. In this case, you are getting a ketone and the aldehyde. So to get ketone, the unsaturated compound must have two carbon atoms. In this case, the unsaturated carbon is this, having only one carbon atom linked. Here also, here also. Here what happens? Two carbon atoms are there. Therefore, it is giving a ketone. The products are easy to predict. Okay, we can easily predict the products upon ozone-lysis. How? Close this. If this compound is undergoing ozone-lysis, close this and put a O. CH3, CH2, CHO. Okay, that there you are getting the product. Okay, CH3, CH2, CHO. Okay, and here close this. Put O, CH2O or HCHO, there you are getting the product. In this ozonolysis reaction, it is easy to predict the product. Okay, for example here, what are the products obtained upon ozonolysis of this isobutane? Here, consider this part and close this part, put O in that place. CH3, C double bond O, CH3, there you are getting the product. And that is one product. Now close this product with this part, CH2, C double bond O. Okay, here it will be HCHO. There you got the product. So the predicting the products upon ozonolysis is very easy. Now let us consider the fourth method. Okay, that is hydration. Okay, or hydrolysis. Okay, hydrolysis or alkanes. Hydrolysis. Hydrolysis is what? Lysis is breaking C bonds. Okay. Hydro means upon addition. Okay. Ozonolysis is breaking of a bond upon ozone addition. Here hydrolysis means breaking of the CC bonds by adding water. Okay. Let us consider the hydrolysis of ethane. That is HC H. What is this called? Ethane. When H2O is added in the presence of dilute sulfuric acid, and in the presence of mercuric sulfate HgSO4. This HgSO4 is a must to get the products. Okay, when ethane is hydrolyzed in the presence of dilute sulfuric acid and mercuric sulfate, you will get a enol. Here H2O means there are two parts, H plus and OH constants. One part will add on this carbon, other part will add on this carbon. For example, H plus is attacking on this, you will get CH, H, double bond, COH, H. See, it is called a enol. Why it is called a enol? En means double bond, you have C double bond. C. Ol means OH. This is a enol, and particularly it is ethanol. It is called as F means two carbon atoms are there. No, ethanol. Okay, ethanol it is called as. Okay, this is a unstable compound. Undergo tautomerism. That is called as a ketoenol tautomerism. That is called as ketoenol tautomerism. Ketoenol tautomerism means we have enol, no? It will take the ketone form. Okay, let's take that. CH3 means here this hydrogen will be jumped or shifted to this carbon. This hydrogen shifts to this carbon. This carbon is already having 4 bonds. No? Now when this hydrogen attacks, this pi bond shifts here. Okay, it will become a C double bond O. Okay, now CH3 I am going to write like this. Okay, CH2 is already there. And one more H is going to attack CH3 single bond C double bond O H. This is nothing but CH3 CHO. This is nothing but CH3 CH3. What is the name of this compound? Acetaldehyde or ethanol. The common name is acetaldehyde. The common name is acetaldehyde. And IUPAC name is ethanol. IUPAC name is ethanol. Here AL stands for aldehyde. Okay. That is the suffix of the aldehyde. Okay. See, by this hydrolysis of ethyne, you are going to get an aldehyde. Let us consider the hydrolysis of propyne. Okay, what is this? Propyne. Add water to this molecule. Okay, in the presence of dilute sulfuric acid and mercuric sulfate What happens? Consider the H2O is an addendum, means we are going to add this, so it is called as addendum. It is H plus and OH minus ions. Okay, and here this is an asymmetrical alkyne. What is meant by asymmetrical or asymmetrical? Here we have triple bond. This side we have one carbon and this side we have two carbon atoms. Come to this. Here we have triple bond. This is a one carbon. This is also one carbon. Okay. This is a symmetrical alkyne. This is a asymmetrical alkyne. In this asymmetrical alkyne, we have to follow the Markovnikov's rule. What is the statement of that rule? What is the Markovnikov's rule? It states that negative part of the addendum. It states that negative part of addendum gets attached to unsaturated carbon with less number of hydrogens. What is the negative part here? This is the negative part. It must be attached to the carbon, unsaturated carbon with lesser number of hydrogen. Here we have one hydrogen. Here we have no hydrogen. Therefore, this is the carbon to which the negative part must be attached. Okay. So, positive part will be attached to that. If the addition takes in this way, it will give you a stable product. What is the importance of the Markovnikov's rule? During the addition of a reagent to the asymmetrical reactant, the stable product can be predicted by using the Markovnikov's rule. Okay? Yes. Here we will get CH3, COH, CH3, COH, and here triple bond will be converted into a double bond during addition reactions. Okay. Here double bond, and this is a CH2. This is again propanol. Okay. 1-ene 2-ol. Simply we call this as enol. Okay. It is a propanol, enol. It undergoes a keto-enol tautomerism. Which kind of tautomerism? Keto-enol tautomerism. It means enol will undergo to ketonic form. Okay. Yes. How? This hydrogen will be shifted here. This double bond will shift here. So you will get a CH3, C double bond O, CH3. So what is this called? Acetone. This is the common name, are also called as a propanol. This is a IUPAC name. Okay, you remember the importance of acetone is it is used as a nail polish remover. Why I am telling it repeatedly? Because in most of the examination, in theory examinations or CET examination, It is asked many times. Okay. Yes. It is all about the general methods of preparation of aldehydes and ketones.